Alright, welcome back. In this lecture, we are going to talk about multiples. And there's a couple terrible definitions of multiples out there, and I tried to pick one that I thought was the best. It says the multiples of a number are what you get when you multiply it by other numbers, such as if you multiply it by 1, 2, 3, 4, 5, and keep on going and so forth. So, for example, a multiple that we could have, let's say we want to find multiples of, I don't know, let's try to pick a nice number, 7. That's not really nice, but we're going to go and live with it. So, a multiple of 7. Let's say we multiply 7 by, I don't know, these numbers they listed here, right? There's a bunch of them out there. We could say 1 times 7 is 7. So 7 is a multiple of 7. Alright, that doesn't really tell us much. Let's see, let's say another number, 2 times 7. Well, 2 times 7 is 14. 14 is a multiple of 7. Okay, maybe you've seen a little bit more there. Pick any random number, right? I'm just using these numbers here, but you can pick anything you want. 3 times 7, 21. 21 is a multiple of 7. So multiples of 7, we have 7, 14, we have 21. If you kept on going, you'd have 28, you'd have 35. Keep on going forever and ever and ever, and that should be a dot, dot, dot. We could have infinite number of multiples. So, what we are going to do is talk about a more specific multiple. The least common multiple. Now, the least common multiple is usually found between two numbers, maybe 3 numbers. We try not to get too much further than that because it gets obnoxious. And we use the prime factorization to help us find common multiples. We can list off multiples, but that's not the easiest method. So, this is just one method. We are going to specifically use the prime factorization method. And I'm sorry about my eyes. They won't dot. I can't use my Wacom tablet correctly. So prime factorization. And I can't spell it either, so that doesn't help either. Alrighty. Stop that. Okay. So the first two that we're going to find a least common multiple between, and we're going to pick nice numbers. Let's say we have 12 and we have 28. So, what we'll do is find the prime factorization of each number. 12 is not prime. I can think of 2 numbers besides 1 in itself that will get me 12, like 2 and 6. If you use 3 and 4, you're going to get the same prime factorization. That's the beauty of prime factorization. So 6 can break down to 2 and 3. Those are both prime. So that's the end of the line for 12. Look, 2 times 2 is 4, and 4 times 3 is 12. So if you had picked that route, you would get the same numbers. Now let's take a look at 28. 28's got, I don't know, 2 and 14. Maybe you picked 4 and 7, or you thought of, I don't know, something else. So 2 and 28, you can break down into a couple of different things. Not too many. 2's prime. 14, we can break it down further. 14, we have 2 and 7. And actually that's the end of the line, so there's no more options. And if you notice, 2 times 2 is 4, and 4 times 7 is 28. Now that you have the prime factorizations, what we are going to do is find the common multiple by collecting the largest group of primes from each number. So I'm going to draw a line. We're going to look at 12, and then we'll look at 28, and we treat them both separately. 12 has 2 2's. Okay, 28 has 2 2's. Well, they have the same number. I don't collect all 4 that I see. I collect the biggest group from one of them, right? There's 2 here, and there's 2 there. 2's the same as 2, so I'm going to take 2. And it's a factorization, which means multiplication. Now, there's 1 3 here, and no 3's here. So the biggest group, I'm going to take one of them. There's no 7's here, and there's 1 7 here. So the biggest group is to take one of them. Now I will multiply these numbers together to find the least common multiple. 2 times 2 is 4. wow, I just can't write today, so I'm going to erase that. That looks horrible. 4 times 3 in the meantime, if you guys want to think about it, is 12. And 12 times 7 gets us 84. So 84 is the least common multiple between 12 and 28. What that means to us is we could take 12, times it by something, and it'll get us 84. So 84 is a multiple of 12. We could also take 28, times it by something, and that will get us 84. Actually, we could see these quite easily. 12 times 7 we already did. We know that's 84, right? But look at your prime factorization. It helps you out. 2 times 2 is 4, times 7 is 28, and the only missing piece is the 3, so I'm betting 3 times 28 is 84. You're probably thinking, I have no idea where you got that from. Well, test it, right? 28 times 3. 8 times 3 is 24, carry the 2. 3 times 2 is 6, plus the 2 is, hey, look at that, 84. What I did was the prime factorization is components of all the numbers that we're using, right? 12 and 28. So in the prime factorization that we found here, that I'm circling right now, are the components in 12 and 28. If they're not, then this is not a multiple. So I said, oh, 28 was 2, 2, and 7. So I checked off 2, 2, and 7. Well, the only number left behind was 3, so that's how I knew 3 times 28 would get us 84. This is useful when we want to add fractions. And let's see if my next slide does that. Oh, it talks about least common denominator. Who cares? Add fractions. So what we are going to do, let's say, for example, we want to add 1/12 plus 1/28. In order for us to add fractions, the denominators, the 12 and the 28 here, would have to be the same. Ugh, right? Well, let me give you the rule. Here's the rule. When we're adding any random fractions, let's say a over b, plus any other fraction, but this time here's a catch, its denominator is the same as the first one. If the denominators are the same, then we can add them. We leave that denominator alone, and we'll just add the numerators. That's our rule. Now we'll look at the one above. The denominators are not the same. So what we are going to find is the least common multiple of the denominators, which we usually shorthand to least common denominator, right? Least common multiple of the denominators is a mouthful, so we say least common denominator. And we're going to make these denominators become the same. How we are going to do that? I'm going to get a new page because it turned into a mess. Let's look at 1/12 plus 1/28. We can both agree 12 and 28 are not the same, but we can manipulate this, and we'll say, okay, can I make 1/12 have it where it has a denominator, which we already found. We said the least common multiple of these two. Actually, I don't remember what it was. Let me scoot back. We said it was 84. So the least common multiple was 84. Can I make 12 have a denominator of 84? What would be the numerator? So we go, what times 12 gets us 84? Well, actually, we already know that. We said 7, right? So if I multiply the bottom by 7, I got to do exactly the same thing to the top. So I have 7 over 7 times 12 is 84. So this question mark is really supposed to be 7. We do the same story for 28. So we have 1 over 28. And we want to have 84 for the denominator. So we want to know what times 28 gets us 84. Well, a little bit earlier we did 3, right? You scoop back in the video and find it. And 3 times 28 gets us 84. And 1 times 3 is 3. So now I can rewrite this problem with equivalent fractions, namely these guys over here, and not change anything. So instead of, and let's just make it look a little bit nicer, instead of 1/12 plus 1/28, we can view this as 7/84. Why am I viewing that? Just scroll back up real quick here. Oh, we can't quite see it on the full screen. See? 1/12 times 7/7, right? Got us 7/84. So that's where that's coming from. Plus 1/28, it's really 3/84. Do not reduce these fractions. I know they can be reduced, but we don't want to do that. We made them larger so that we can add them, because now look at those denominators. They're both 84. And 7 plus 3 is 10. So we have 10/84. After we have added them, because we wanted the denominators to be the same, now we can try reducing our result, in which 2 can go into both top and bottom, and we are left with 5/42. And there's our answer. Okay? So, what we are going to have to do when we add fractions, let's recap this horrible mess, right? The first thing we're going to have to do, oh, my pen has wigged out. The first thing we're going to have to do is find, and I'm going to type it because I think it might be safer. We are going to find the common, oh, let's be more specific, the least common multiple, or the LCM, of the denominators. Once we find that, if they're already the same, you don't have to do this. You leave it alone. Once you find that, you're going to make your fractions all have that denominator that you found in step 1. Okay? So this guy is step 1, and here this is step 2. So these are what our process we're going through. Once the fractions all have that denominator, we get the beauty of, okay, the denominators are the same, so just add the numerators. Let's see if I can spell. Add the numerators and keep that denominator you found. You did all that work for the denominator. Why would you get rid of it? Leave it alone, okay? Once you have that, you do your final last check. Sometimes you don't have to do this, but if you can, check if you can simplify. Subtraction is the same way, and what we're going to do is a couple of problems, and then we'll have lots and lots of practice with these. So I'm sorry, my camera is not recording quite the best, so I'm going to have to redo this video. If you guys will keep that in mind, I will see you guys tomorrow.